Hey everybody, I wanted to review for the test coming up. I'm going to be that guy. I'm not going to give you the exact questions that are going to be on the test and give you the questions to try before you get there. But I did want to go over some questions that pertain to the exam, and if you can get the concepts behind this, I think that that's important. Also, I know that there are some sample problems that I've worked before this, so use as much or as little as you want to. Right now, we're going to work on question 15.63, and which is Le Chatelier's principle. So the interesting thing about Le Chatelier's principle is that whenever you put a stress on the system, the reaction is going to shift to compensate for that stress. So this question here is good because it doesn't even have a specific reaction. It just says, how do the following changes affect the value of the equilibrium constant for a gas phase exothermic reaction? So what we know is that the general form of a reaction is reactants are in equilibrium with products, and I put gas here because we know that it's a gas phase reaction and it's exothermic. So the fact that it's exothermic means that delta H doesn't even matter what the value is, it just matters that it's negative. So if it's negative, that means that delta H is a product of the reaction. Okay, now, so going through this, I can figure out what's going to happen to the equilibrium constant. Okay, so removal of a reactant. Okay, when we remove reactants, okay, that's not going to change the equilibrium constant. The only thing that changes the equilibrium constant is a change in the temperature, or if you have a separate reaction altogether. But I think that that's fairly obvious. It's only when you change the temperature does the equilibrium constant change. Okay, so if we lower the amount of reactants that we have, yes, the reaction is going to shift this way, but for part A, it's going to be unchanged. Okay, I'll put unch there. Okay, now for part B, okay, same thing, same idea, is that now we're going to deal with the products. Okay, and the products are now going to be removed. And so you remove a product, and so the reaction is going to shift toward the product. But again, you're not changing the temperature, so it's going to stay unchanged. So when you decrease the volume, again, now when you decrease the volume, you shift in the direction of the side with less moles of gas. But again, we're not changing the temperature. So while the amounts of the products and reactants may change, the constant is going to remain unchanged. Okay, and then let's see, now we decrease the temperature. Okay, so now the temperature is decreasing. As the temperature decreases, Le Chatelier's principle says we're going to shift to the side in order to fill the void or to alleviate the stress. And so to shift this, we're going to shift toward the products here. Okay, and so when we shift toward the products, let's write our K, products over reactants. That means that products are going to increase, and therefore the K for D, the K is going to increase. Okay, and the last one, the addition of a catalyst does not affect the equilibrium constant. The equilibrium constant is only affected by temperature, and so this affects the speed with which the reaction occurs, but it does not affect the constant. So I hope that this solidifies the point that the only thing that affects the value of the equilibrium constant is change in temperature, Okay, so have fun and have a great time.